All right, we're going to continue the last video. So in the last video, we discussed substitution rule for the double integrals, so the formula is given by here. It, it is crucial to find jacobian, which is used when we change dx dy into du dv. So you need to multiply by jacobian. And another thing is how to correctly figure out what g is. So the thing is that you need to find correct boundaries and correct integrand. That's what you want to do. So we had one example two, and now we continue with some more examples to get this familiar with. So here, write the Cartesian integral dx dy form into polar integral. What it means is, so we have Cartesian system for coordinate system, right? So xy plane basically. Then any point in the in two-dimensional plane can be either written as, so suppose you have a point, then you have a point here, then either you can write this as xy, where x is x coordinate, y is y coordinate, right? Another one is we can write this as polar coordinate, which is rho theta. Rho, so x is here and y is here. And rho means how long of this arrow is. And theta means what's the angle formed with this arrow and x-axis. So those are two equivalent coordinate system, and polar integral is sometimes used to some particular form of double integrals, and it gives great simplification for those a class of structures. So this is one thing we want to discuss. How should I write? So again, so if you make a little bit detail for here, when I write this, what is correct form of f? Maybe f is in terms of some rho theta, right? So I can write rho theta and y rho theta. So maybe I should, so what is correct form of this? And I need to multiply by a Jacobian and d rho d theta. So you need to find out those things and those things. Of course, Jacobian too. All right, first we need to understand what's the relation between how to convert x and y into rho and theta, right? So we want to know what is x in terms of rho theta, then it is rho cosine theta. So from this triangle, right triangle, y is rho sine theta. And this is basic conversion formula from polar coordinate to Cartesian coordinate system. Now what we do is first I want to find what is Jacobian for this system. So this is x rho, x theta, y rho, y theta, right? And x rho, so look at here, then rho derivative means cosine theta. So we have cosine theta. For x theta, it's rho negative sine theta. And for y, it's similar. So sine theta, y rho, and y theta is rho cosine theta. And we calculate, then this is rho cosine square theta minus rho sine square theta. So eventually this is rho cosine square theta minus become plus, rho sine square theta. And we know that cosine square plus sine square equals 1. So this simply rho. So Jacobian is simply rho. It's surprisingly simple for this conversion. So we can write this here. So instead of doing so and what do we need to put here? It is so here x is replaced by rho cosine theta, y is replaced by rho sine theta. So we can write this as maybe for each problem g is different, so a little bit different. So not a little bit, but you have g, the shape of g depends on what actual problem is, but otherwise we can write this directly. So f x is rho cosine theta, y is rho sine theta, and then when you write dx dy, you multiply rho, which is Jacobian, d rho d theta. That's what you do. So this is the formula or the answer we're expected from this example. The next example, this is non-trivial problem. So we have double integral in xy coordinate system, and we want to use UV plane, which is giving the transform or substitution rule. So to do that, we can look at, so we first need to solve for what x and y's are in terms of UV. So if we multiply these two, then so if you think about multiply this times this, left hand side is UV, right hand side is square root of xy times y over x, right? And x cancels. So this is square root of y squared, and this is simply y, not plus minus y, because y cannot be negative. Because from here we see that y ranges from 1 to 2. Smallest number y can take is 1. So this is square root of y squared is simply y. So y is u times v. So y equals u times v. Another thing is you can just divide these two. So u divide v, then it is square root of xy divided by y over x. So then this is square root of x squared, and this is again x, because x cannot take a negative number. Looking at dx, then it takes a number in between this and this. So smallest number it can take is 1 over y. And y is always positive. It is between 1 and over 2. 1 and 2. So the positive number reciprocal is positive. So x is always positive. So x is u over v. So this is the first step. Now we can do the Jacobian. Jacobian is xu, xv, yu, yv, which gives me xu is 1 over v, xv is negative u v squared, yu, yv, and to the multiplication minus, so this multiplication minus this multiplication. So minus minus becomes positive, v u v squared. So this is u over v twice, 2u over v. So this is Jacobian. Now we look at the boundary. So we have 4 curves. So what 4 curves do we have? The first curve is from, so x upper limit is y, right? X upper limit is y. And y upper limit, x lower limit is 1 over y. X lower limit, 1 over y. And number 3 is y upper limit is 2. That's from here. And y lower limit is 1. So we have basically four curves in xy plane, and we're going to transform this. Then so we need to go through transformation, which is given by as this formula. So here is the substitution rule we're going to use, right? And so if you put this here, then basically 1 prime gives me x equals y, so uv equals u over v, which means, u cancels, so v squared equals 1, which means v equals 1. Now, if this goes through the machine, then it becomes uv curve, so this means xy equals 1, right? X times y, so u over v times uv equals 1. So v cancel, u squared equals 1, which means u equals 1. So now I feed number 3 curve, so we get after transformation. Y equals 2 means uv equals 2. I don't have anything to do for any further simplification. If 4 goes in, then yeah, so 4 goes in, then it's again uv equals 1. Yeah. So what 4 curves do we have? What region, what shape of domain do we have in UV plane? So UV, first of all, V equals 1, right? So V equals 1 means suppose that I get this is 1, then V equals 1 is some horizontal line. So this is number 1, and U equals 1 means, so if I say here, so this is 2, V equals 1, U equals 1, and then we look at UV equals 2. UV equals 2 means it's a hyperbola, but it's going through this and these two, so something like this. And this one is UV equals 1, this is a little bit lower hyperbola. All right, so originally region R is enclosed by, surrounded by these 1, 2, 3, 4. Now, after transformation, you have 4 new curves which surrounds the domain G, right? So if you look at this, it's gonna be this area. Oops. So it's gonna be this area. So it's like triangular, but this, of course, this is not triangular because this is not straight line at all. All right, now what we do is we are going to do calculation. So our information, if you collect, we have 2u over v as Jacobian. So and also so if I look at, so if I'm, so this is final step, but we need to collect all the correct information for this. No, sorry. So it is, we want to write this, and when you write dx dy, I want to write du dv instead, and then multiply by its Jacobian, which Jacobian is 2u over v. So 2u over v. Now here we have, so y over x, square root of y over x. Square root of y over x is u, right? And this square root of xy is v, and this is u. So this guy itself, it becomes v times e to the u, right? So I can write v times e to the u. And then we have this shape. This is not just rectangular, which is we wanted, we hoped, but so we can look at for this we're going to look at dv du order. So we are screening or collecting coins along vertical lines. Then yes, then I can put this as dv du. Of course, you can try the other order, but I believe in this way it's easier. And from here, every stick, so when I look at this vertical stick, so v, this is v plus, right? V plus is living on this curve, uv equals 2. So u v equals 2. Solve that. V plus equals 2 over u. This is for upper limit. And when you look at this one, then it satisfies v, it's on the curve 1, right? So v minus equals 1. So it's your stick is starting from 1 to 2 over u. So from 1 to 2 over u. And for u range, so you're moving this stick from this line. This is first line you're starting, so which is 1, and ending at this, you're moving this to here, so which is 2 here. So from 1 to 2. Now next computation, v and v canceled, so inside of this is nothing related to v, right? So also I can take out 2 if we want it. So 2u e to u to the u's power, and this is just placed as a constant and multiplied by v, which is antiderivative, and substitute, then this is 2 over u minus 1 and du. So that is the inner integral. And then we compute for I can take out 2 here outside, and I put this here, distribute, then 2, 1 over u and 2 minus u. This way I can eliminate the fraction, and then e to the u, I can, e to the u times du is deu, so by chain rule, right? And then now we can use integral by parts, so 2 eu 2 minus u minus 1, 2. I can switch around these two, so e to the u d 2 minus u, right? And put 1 and 2. So 2, this is 2 eu minus u eu minus this guy is simply d2 is 0, constant differential, so du minus. So negative sign becomes positive sign, so 1 2 eu du. 1 2 is already here, so I can just simply skip that 1 and 2. And this is 2 eu minus eu, and this is antiderivative is eu, and 1 2. And then for 2 it means 2 to the e2 minus 2 to the e2 plus e2 minus 2 to the e1 minus e to the 1. Oh, and this is minus becomes positive, and minus e to the 1. So it's weird. I have a lot of things cancelled. So at the end, if everything correct, then this is the final answer. All right. So that's the end, and we're going to stop this video.